Okie dokie. Let's keep cooking from last class. Shut up. All right. All right. So we were starting to talk about C versus Java, right? And then I was sort of wrapping in some commentary about C sharp, I think. All right. So let's see if we can power through that and get into some Java syntax here pretty quick. All right. So Java, made by Sun Microsystems, which was now they were purchased by Oracle. And Sun Microsystems was effectively all in on Java. For those of you who are into the stock market, their ticker symbol on the stock market was Java for Sun Microsystems, not like Sun or something. It was actually Java. So just like all the other languages we've talked about from last semester, Java is directly based on C++. In the early days of Java, they actually called it C+++++. It just kind of cleaned up some of the stuff from C++, and I think you'll see that pretty early on here this semester as we kind of rewrite what we were working on last semester in Java, and you'll basically see, 95% similarity with just a couple of things that you said, oh, you know what, that used to be annoying, and no, I don't have to do that anymore. So I think you'll appreciate Java, and that's why we do C++ first. It's considered platform independent. We talked about this last time, the idea of writing software, and really Java was born out of a time, once again, it's the Mac people who, make our lives harder, right? A lot of Mac users were complaining, gamers for Mac, which shouldn't exist. If you're a gamer, you get a PC is what you do. But anyways, the gamers for Mac back in this had to be the mid 1990s. They were complaining that, all the games are coming out for Windows, not for Mac. And why is that? Well, we talked last class about what compiling requires. It's not just the language. It needs to know the architecture, and it needs to know the operating system. So when the game developers wrote a game, and they wrote it for, the early days of DirectX, which is Windows, Microsoft's 3D rendering software, and for the Windows operating system, even though actually back then, Apple was running PowerPC processors. They weren't even Intel as well. So they were even incompatible at the architecture level. So you had Intel versus PowerPC, you had Windows versus Mac OS, and then you had DirectX versus OpenGL. So they were incompatible at all levels. So when you recompile that software, especially the OpenGL code was the problem. All the 3D graphics stuff that were written into these games, which, by the way, if you didn't know, games are typically graphical nowadays, so that would be a lot of the stuff. If it was written in for DirectX, that was only going to work on a Windows machine. They would have had to rewrite that software using the equivalent 3D stuff for OpenGL through the equivalent libraries or whatever. So it would have required physically rewriting code, not just recompiling it. All right. So, of course, you had the less than 1% of the population of users who were on Mac versus PC at the time, but they scream really, really, really loud. So they were whining, and the belief was that Java was kind of born out of that complaint, where it's like, hey, here's a language that if you write all your software using Java, it doesn't matter if you're on a Windows machine or a Mac or a Linux box, whatever, it'll just work. Because what we did is we went ahead and we wrote the Java virtual machine for Windows. We wrote the Java virtual machine for Mac. We wrote the Java virtual machine for Linux and for all these other platforms that you might want to run Java code on. And compiled Java code will run on the Java virtual machine, regardless of where it is. But that came with the trade-off of a little bit of performance. And games, the things that they were really complaining about, require that performance. So basically, if we think about in today's world, games written in Java exist, and there's nothing wrong with them, but it would kind of be those games along the lines of like Angry Birds, that kind of stuff, not Call of Duty. There's going to be too much sluggishness in that translation in order to expect that a language like Java is going to allow you to, you have to create a significantly lower graphics fidelity version of Call of Duty in order for modern day fast processors, which they are, to fake it enough for you to make you feel like it was full speed. Not going to cut it. But Java found its home really for business applications. I think I mentioned last time, probably, if any of you are into stock trading stuff, or you heard about the whole industry of day traders and things like that, and when you have a whole bunch of money with one of these places, they give you access to their professional day trading platform. All of that stuff is written in Java, so it doesn't matter what kind of computer you're in. Your entire day trading application launches out of a web browser as a full running Java applet on your computer, and is plenty fast. Business applications, no problem whatsoever. Java's perfect for that. All right, so Java is very, very, very popular, especially in the business world, and it's fast enough for basically everything but the highest end games. So it's not that Java is slow. Okay. So then let's go ahead and take a look at Hello World, C++ versus Java. All right, so we'll bounce over to our C++ version of this guy. So in here, we're including our IO stream. This is just a review of the stuff from last semester. This gives us access to the stuff for writing, to see out, to write stuff out to the screen. We are including the namespace standard, which gives us full access to that. So we don't have to write std : cout. We just have to write cout. Then we have, remember from last semester, I mentioned all methods, all programs begin and end with main. Okay, so we have our main method here. In this case, it's taking no parameters, but we did point out last year that the early traditional version of this would have taken in an int argc and a char pointer argv. This is a string array. So you could even look at this like that guy if you like that syntax a little bit better. So an array of char pointers, that's an array of strings. All right. So, and if you remember from last semester, well, tell me, why did I need to take in the number of arguments as well as the array itself? Go ahead.
It doesn't know the length of the string itself.
Yeah, well, it knows the length of strings, but doesn't know the length of arrays. Arrays, yeah, right. Arrays can't advertise how big they are. So we had to keep track. This is how many arguments were passed into the program. This is for command line arguments. All right. Anymore, we double click an icon and it launches. There still is probably command line arguments behind the scenes, but in the early days when we actually launched our program, we may have given it some command line arguments, but that's entirely what this stuff is for. So this is the number of arguments that were passed in at the command line, and this is the collection of those things so you can use them inside your program. All right. And these are optional in C++, but I just wanted to throw it in there because it's not optional in Java, and we'll see it here in a few minutes. And then we want to write something out to the screen. There's our cout hello world, and then we end the program. Okay, so that is hello world in C++. Let's give myself something. Let's see how bad this looks. Oh, it's not bad. All right, that's the C++ version of hello world. All right, let's look at let's see how well it writes it here. Otherwise, we'll just write it. Okay. Oh, I didn't rewrite it. That's fine. I'm going to just rewrite it. All right, so hello world in Java. Public. Static. Void. Main. String array. Args. System.out.println. Hello world. All right, that's hello world in Java. Notice we still have a method called main. All programs begin and end with main. This guy does require that you pass it an array of strings, but in Java, arrays can advertise their length. So we only needed to pass in one parameter here, not two. Because the array can say, so args.length. If I did system.out.println args.length, it would tell me the number of elements that are in that array. Okay. So this is hello world in Java. If I go ahead and hit run, are we still running it as a C program? I bet you. Who? What do you? Oh! I didn't put my public class in there. Blah blah blah. So technically, I didn't actually give you the full hello world program yet. For a file named main.java with a capital M, this has to live inside of a class called main with a capital M. So I guess I can amend this. So there's our hello world. And there's our 0 because we did not actually pass in any command line arguments. I think we actually can pass in command line arguments. This allows us to do it somehow. Oh, I could just end this, I think. Cat, dog, and we'll run this. This should show us 2 command line arguments. So there's our 2. Okay. So there's your hello world. I'm going to take out this second line there. So in every single program in Java, you will have a class. Classes were introduced to us in C++ when we started talking about objects, right? So Java is 100% an object-oriented language. C++ was the object-oriented extension to the programming language C. All right, so we started off writing our programs in C++ in a procedural manner. We didn't have classes. We just had our main. So we look at main here. There's no class involved here. When you run your program, it runs the one that has main in it. Same thing's true with Java, except your main method has to be embedded inside of a public class. We didn't talk about public, private, protected last semester. We will talk about it this semester. But this has to be public in order for the Java virtual machine to definitely be able to run it. Okay, because this is going to be sitting in some sort of user directory somewhere. You might have this main.java file living on your desktop of your computer, something like that. All right, so it has to be public. Not a major deal thing there. So that's hello world in Java versus hello world in C++. Let me just show you a couple of things here. Just going to say line 2 there. Technically, this is the equivalent to what we had before. System.out.print will print out a word. a string, and leave the cursor at the end of that line. Remember last semester we had to do an end L to kick it down to the next line. So this will keep everything on that same line if you don't do print lin, instead you just do print. So that's why we say hello world, and then line comes right after that, as opposed to throwing the ln at the end of that function. And now it kicks it down a line. All right, so no more outs and stringing a bunch of things together with an end L at the end to kick it down a line. Now you just do print lin when you want to kick it down a line. We'll talk about that. Just that the quick answer to that is any method that's static belongs to the class. It's a class method as opposed to an instance method when we don't have static, and we'll see examples of that.
So the capitalization method.
Yeah, just like C++. This didn't have to be called main. This could have been called cat, but it would have needed to be in a file called cat.java. So whatever the name of your file is here, that must be the name of your class.
So it's going to the file to the argument.
Well, that's why it probably makes more sense to am I able to rename this guy? No? Oh, whatever. I would likely never call it main.java. I would probably call it something like wherever my main was, I usually would call that file driver. Let's just see if it lets me get away with it in here. So I'll call this guy driver.java. I'll explain why here in a second. So that would be my program. I'm going to just go ahead and gut this one and see if this dude will be okay with finding the thing, or if it hard codes in that it's looking for a file called main. Yeah, it's specifically looking for the main class. That's not a Java thing. That's an online GDB thing. That's why they named their main thing main. No way really around that using online GDB. Yeah, it won't let you rename this file. So it's just part of how online GDB makes their thing work. But typically, if I was doing this in another IDE or something like that, I would name my class driver like this. When you think about, so if any of you have ever installed like a graphics card or something like that, then you have to install some software. That's the drivers for that. Okay, what does a driver mean? We've heard the word, but why do they call it a driver? Yeah, it's a software that drives that hardware, right? It acts as the intermediary between the operating system and the physical hardware. All right, so when they build these graphics cards, so how many of you in here, just this is more of a gamer question, have ever put a one of these higher end graphics cards into a computer? All right, several of you, right? When you first put it in, sometimes your computer launches up and it's in like that 640 by 480 resolution with almost grayscale. It looks like crap, right? You just spent $1,000 in this graphics card. It looks 100 times worse than it did 5 minutes before. That's because that graphics card is built to be what's called VGA compatible. Sometimes it's probably SVGA, super VGA compatible. That means that is the lowest common denominator that basically all operating systems use to use a generic graphics card. That is to make that card work when you first plug it in, to give you the opportunity to install the driver software that turns on all the bells and whistles, right? Because what it does is it takes, like here, your operating system will already know how to talk to this guy using VGA. But then once you install this other software, now we've introduced 1,000 other things that now take advantage of all the expensive stuff that's in this card that wasn't part of graphics in the 1980s. And that's when you reboot your computer and things start looking way better, right? All right, because now it's actually instructed the operating system how to truly interact with that card instead of that initial interacting with it at that lowest common denominator just to get it to work for you to be able to install the software. Make sense? That's what's going on there. So whenever you buy any new piece of hardware, even USB stuff, you plug it in, your computer recognizes that as a generic USB device, you know, and then from there it figures out what is it actually. If it's a keyboard or a mouse, it probably can install the software itself, but you get some of those gaming mice with the 4,000 buttons on it, right? You might have to install an additional piece of software that comes with the ability for you to map all the buttons to the things that you want it to do, because that's not a normal mouse, right? That's a super duper mouse. That the operating system did not natively know how to do that. And that was actually a big move in operating systems to allow for software drivers. Because you roll back to older operating systems, let's just go back to like a Unix operating system in the early 90s, late 80s. Basically, all the drivers that were ever going to exist had to ship with that operating system, which meant that hardware creators could not create fancy schmancy things and have them come out later, because they would not have worked on that thing. They would have had to work with the operating system creator to make their next release of the operating system have support for that thing, because the operating systems did not have modular driver support. It had to be built in, compiled into the operating system itself. Modern operating systems have modular drivers where Windows comes with a collection of, hey, here's all the crap we knew about when it first shipped to make your life easier, right? All the generic stuff, plus some other stuff. Sometimes, like a lot of the NVIDIA cards anymore, Windows does have a default driver for it, and it looks decent right off the bat. But you still want to put in your NVIDIA experience driver to open up all the extra crap and also get the updates to it and all that stuff. But the point is, modern operating systems have the ability for you to add driver support after you've installed that operating system without having to wait for Microsoft to release, version 2 of that operating system with the service pack 2 with some new driver support or something like that. All right, so that's kind of the evolution of our operating systems and why our hardware, every 5 minutes we get a, if you bought a graphics card last week that was top of the line, next week it's number 2, right? Graphics cards are a little bit more sluggish than that these days because of the crypto miners, but that's kind of going away now with their change in how things are working. But anybody in here have an NVIDIA 4000 series, something? Yeah, my 4090 Ti should come, I think, in a couple weeks. Because 3090 Ti, I'm going to use that just kind of to prop up my bath mat, so the water kind of rolls off of it. I have 64 gigs in my. You don't need more than 64 gigs in any gaming computer these days. But I have 96 cores of processing. Not that you need that for gaming either. Not even that. You'll notice more cores will help the most. We've used the example in here before. We'll use it again when we get into threads here pretty soon. When you have work that can be divided up, maybe even use the example last semester of like, if you can shovel snow at speed 10 and the rest of us in here could shovel snow at speed 4, but we all work together to shovel the snow on campus and are competing against just you, who's going to get the campus shoveled more quickly? Okay, because that's a job that we can divide it up into individual pieces, right? Graphics rendering is a big thing for that. So more cores for people who are doing like animation rendering and stuff like that. That's where it really makes a difference. Or, if you've ever had to download a video online and converted it to another format so it works on whatever your not illegal streaming thing is. If you try to, if you have like a MacBook Air or, a low powered computer and you have an 1.5-hour movie, it's probably going to take 45 minutes to convert it to a different thing. And so even though that computer feels very, very fast under any other circumstance, maybe it feels just as fast as my desktop computer with the 96 cores, right? That same video will probably convert in about 40 seconds on my computer because I can divide that work up 96 ways. It's just the nature of that job. But for a video game, they do use multiple cores, but probably they're not using more than 6 to 8 cores, and they're probably only using about 4 cores max for which require performance. So you'd much rather have 4 really, really, really fast cores on a processor than 96 cores that are even slightly slower. If you're a gamer, you want the fastest performance across fewer cores. That's the worthwhile trade to having a zillion cores if you're a gamer. Call of Duty is not going to run better on 48 cores than it does on 6 cores, because it's not going to use most of those cores. All right. Questions about I don't know, Hello World and Java? Go ahead. Nope. In fact, right here you see the word void. Void must be main in Java must be void. So basically, here's the deal in Java, and so put this into your memory bank somewhere. At some point, it'll be a quiz, or maybe it'll be on an exam or whatever. I'll ask you to write an error-free Hello World program in Java. Okay, that's one of the things that I think that even though I teach that all programming language are the same, programming is the skill set or whatever, I think an important thing for you to have as a programmer is the ability to get a working Hello World program in whatever language you're about to use going right off the bat. Sure, you can just Google it and get it working. I get it. Okay, but bottom line is, before you start writing a bunch of logic and stuff, get your environment working. And that's where Hello World starts. Where it's just like, look, I'm gonna run this program and it spits out Hello World. That means that what I have here, everything's in the right directories, my compiler is set up right, all the other stuff is set up right. So in Java, you have to have a public class. The name of the class has to match the name of the file. The method is public static void main. It has to be that way. I think you can actually flip around public and static, but whatever. This has to be a string array, but you can call it whatever you want. The name of the I was going for elephant, but we'll just, that's a C minus. C minus for a first grader. The name of that variable doesn't matter. Just like we've learned before with functions, whatever you name your variable here, that's what you'll call it down in here when you go to use it. Okay, but it has to be a string array, and that matches right up to C++, where we took in a array of strings, and then we also had to pass along how many strings were in there, because C++ arrays could not advertise, well, it's really C arrays, could not advertise the number of elements that were in them. Java's can't. So right off the bat, we see our first benefit. Java arrays know how many buckets are in them. They don't necessarily know how many buckets you've used. Because you create an array, the same rules apply, right? Arrays, when you first create them, here, we'll just go ahead and make one. So if I want to have an array that holds 10 elements, int array AR is equal to a new int array 10. Like that. Notice it's a slightly different syntax, right? In C++, we had int AR 10, like that. And remember, this guy was the shortcut guy, but had some, here, I'm going to ask the question here in a second, as opposed to int pointer AR is equal to the int pointer version of malloc 10 times size of it. That guy. So obviously this guy looks way cooler, right? We covered that last semester. So when you really want to impress, the people in Walmart, it's like, what do you do for you? I'm a programmer. You bring up that stuff. You don't bring up the Hello World program, because that makes you look smart, even though none of us like this either, right? Well, I kind of like pointers, but I spent a lot of years where this was the only option. So that's more of a throwback. What's the difference between these two? When might you use the second one versus the first one? Because at first glance, you might say, oh, this just looks like the better way of doing it, right? Like, or my phrase I use is syntactic sugar. That's syntactic sugar for this long drawn out thing, which might be true 95% of the time when you use this, but there is a difference. Is there somebody who got it? Go ahead. Memory does get allocated in both ways. If I'm gonna fill in a couple of gaps for you, it does make a little bit difference who allocated the memory. In this case, since we're calling malloc memory allocate, we are the ones requesting the memory. In this one, we're asking the C++ compiler who's talking to the operating system. We're asking them to allocate the memory. Memory is still being allocated. But that does have an after effect. Anybody want to go ahead?
So the first one, C++ response whenever get rid of when it wants. But the second one, your response is correct. So you have to deallocate it and run it.
Yep. So that's really actually a great way of putting it. Since C++ is the one who was responsible for allocating that memory, it gets rid of it when it wants to. And if you allocated that memory at the beginning of a function, C++ wants to deallocate it at the end of that function. Even if you didn't want it to go away yet. Make sense? If you had assigned it to another pointer somewhere, like a global variable or whatever, it will disappear on you. As opposed to if you allocate it, okay, now you made the mess. C++ is going to rely on you cleaning up your mess eventually. Most of us are bad programmers and we don't. It's like, look, you got 64 gigs of RAM, deal with the spillover, right? You know, that milk will dry. that kind of thing. But the difference is that if we allocate the memory, it's C++ will not try to guess when we want it to go away. It's now up to us, so it'll persist. So when the function ends where we allocated it, if we had at least preserved the pointer, set that pointer equal to something else that was accessible outside, the stuff at that memory address will still exist. All right. So even though these guys both create the same structure, it's when that structure goes away that makes the difference. Go ahead.
By ourselves, like, I mean, so, okay, so the first one, when is it? So it deallocates at the end. Right?
Yeah. So let's just give you a legitimate example. And then just bear with me for a minute. I'm going to, I can't really do this in. Oh, well, I'm doing C++ stuff right now, so this is okay. I'm mixing C++ inside of a Java program. Just roll with this for a minute. So I created a variable, a global variable that knows how to hold a memory address of an integer. I have this function called do something that maybe I call from main here, assuming we prototyped it. Okay. And this guy, he creates an array using what looks like the simple syntax, but it's the syntax that C++ gets to decide when that memory goes away. So this is going to result in AR being a memory address. I'm then going to set whatever AR is, which is a memory address, equal to my variable called remember array, which is global. So that means that after this function ends, this variable still exists. And it was my intent for that variable to still hold on to that memory address that was created inside that function. So I still had access to the elements of that array after that function was over. That was my intent in this case. But what happens instead is at the end of this function, C++ kills off AR, which means remember array points at nothing. So even though I had the intent that this global variable would allow this array to be preserved past the end of this function, it won't be because of the way I created it. On the other hand, if I created it that way, it will persist. Because now I made the mess. I get to decide when it gets cleaned up. C++ will not go and make it disappear at the end of this function. Make sense? So it does have a difference in terms of when it goes away. I might make the generic argument that as long as you're willing to always clean up your messes, you get the most consistency off of you doing the memory allocation yourself, rather than relying on when C++ decides it makes the best sense for it to go away, because potentially that could change when they upgrade the compiler. They might decide, oh, for optimization purposes, we're actually going to allow that memory to persist a little bit longer. And now all of a sudden, a pointer that used to cause an error no longer is an error for at least a time period. So those are a lot harder bugs to find in your program. Okay, so good. Well, deallocating it before you, well, you wouldn't probably deallocate it before you finish it, but let's assume that you were doing something inside of a function that happens to use it. You were doing some kind of scientific experiment thing that crunched a whole bunch of numbers and what used a whole lot of memory. In that case, it might be advantageous for you to create the memory yourself and then also clean it up in the middle of that function to give some memory back, because you might need it again 2 lines later, as opposed to just waiting until the end of that function and letting C++ clean up all the messes. I might make the argument that, similar to when we learned about like if statements and loops, where, you know, technically you don't need the opening and closing curly brace if you're just going to have one statement. But I said that it's never wrong to have the opening and closing curly brace. I would make the argument that from a C++ perspective, you should always create your arrays this way, because even if you don't clean up your messes, they'll at least behave the way you were expecting. They won't disappear on you. A question back there? Oh, yeah, in this case, I would probably do like a delete remember array at the end of main there. That would be me cleaning up my mess at the end of my program. Like, look, I wanted it to persist as I was jumping through all my hoops up here, but later on, that's when I wanted it to disappear. Okay, but the punchline for all of this, and this is a good discussion, because in C++, we had to make these decisions. Make sense? We even if we didn't understand the difference between these two, if we just thought one of them was syntactic sugar from the other one, and 95% of the time, we probably can get away with that if we weren't trying to make the thing persist past the end of the function, right? This syntax might be very helpful a lot of the time because C++ cleans up your mess for you. But maybe you didn't need it past the end of this function. That's perfectly okay, right? That's probably the better choice in that case for that exact circumstance. But what if we could have the best of both worlds? What if we could have memory that behaved as if we requested it, but Java cleans it up for us anyways? But it cleans it up at the end when we're done using it. So if we were doing this in Java, that's the equivalent to this line right here. So what we've done is we've replaced the word malloc, memory allocate, with the new keyword, which we've already seen, right? We saw the new keyword when we introduced classes at the end of 200. We called that guy a real estate agent. Remember, so whenever we see the new keyword, that's the dude who's requesting memory from the operating system on our behalf. So let's clean this up here a little bit. And I'll go ahead and put this guy down here. All right, so now I went ahead and I defined an array. I requested new memory. How much memory? Enough memory to hold this many of those guys. So no longer did I have to cast the pointer back to something else. I didn't have to use size of. Java knew what you meant. I want 10 of those dudes. And I want you to store it inside of this bucket, inside of this array. Okay, now first thing we notice here is this syntax no longer works. One thing that textbooks will often say is that pointers don't exist in Java. Now, how many of you loved pointers? We all loved pointers. 0 hands. Pointers are great. Pointers are great. And we needed to learn about them the way we learned about them. The reason for that is that textbook. If you grab 10 Java textbooks, I bet you 9 of them say pointers don't exist in Java. Now remind me, what's a pointer?
Something that refers to.
Is it a variable that holds a memory address? That's what a pointer is. Variable that holds a memory address. So real quick here, just copy this. Just do a little stuff in here. I'll just rewrite all this other crap. Okay, so I'm creating an array. And then I'm printing out whatever value AR holds. It's running. Oh, this is inside driver. Give me a moment. Remember, we saw it didn't let me do that. Let's get rid of that driver. All right. So again, creating an array and then just printing out whatever that variable holds. What does that dude look like to you? Memory addressy thingy? Kind of a hexadecimal number thingy majiggy there? Do memory addresses exist? Do pointers exist in Java? So 9 out of 10 books just lied to you? And they charge you $75 plus shipping? It's not that pointers don't exist. Let's clarify here. Because again, remember, we're going at the angle here that Java helps us. Java's taken away some of the things we used to have to do. So in Java, pointers exist in Java. Yes. We just do not have a special syntax for dealing with them. Java passes things by address when it makes sense and passes by value otherwise. Java has removed the choice from us. Okay. And instead, Java just says, look, if it should be a memory address, I'll deal with it. But I'm not going to make you have to deal with special syntax for these things, which means the arrow goes away. The asterisk goes away. That ampersand goes away. When you had to decide personally, is this a dereferencing a pointer to another pointer for an array of strings? Is this do I actually want the address of this integer? That doesn't exist in Java, even though pointers still exist. We just don't have the same level of access to them. When in C++, we 99% of the time, we could have made the argument that there was really only one correct way of doing this. Yes, you still made me use the arrow, but this was the correct way of doing it. You couldn't have just made the assumption that this is what I meant. Make sense? Java adds that feature and makes that assumption for us. So in Java, when I use the new keyword, I am creating memory. And if I print out the value of AR is holding the result of the new keyword, which is a memory address. Now, believe me, what lives at that memory address is an integer array with a bunch of contiguous memory, just like in C++. And then we prove that it is a memory address. I can sit there and I can just print it out. And we get a nice little memory address. But that's as far as I can go in Java. I can't start doing math with those pointers, adding 3 buckets, walking through memory, yada, yada, yada. All right, questions, comments, concerns, bribes. All right, we'll pick up here on Friday and probably run into our first assignment over the weekend.
Yeah.